I will say what one.
We starting. Yeah, great.
Hello, everybody. We are going to start very soon. And so we share the screen. So hello, we are Anarita and Filipe. Filipe, you can unmute yourself because you are part of FIELDimageR, besides being the speaker of today. So I'm gonna share the screen with the presentation. So who are we? Just a short introduction on our platform. So how it started and which is our idea. So basically we are two postdocs that we met at FIELDimageR 2020, this year, just in February. After that, many things have happened, including a global pandemic. But basically when we were there, we realized that we are kind of beginners and in plant phenomics, and sometimes it's very difficult to start your own project and find the right tool, contact experts. And so we say, what we create a platform where everybody can meet, like beginners and experts, and they can like share tool knowledge, but also like start collaboration, because that's also important. So we decided to create this platform, which is called FIELDimageR. So we are going to provide many tools in different way, like seminar, workshop. We also have a Slack workplace. So this is gonna be a useful tool. First of all, if you have any problem and you want to ask suggestion from the other people that are part of the community, you can write there. But also it will be a place where you can meet with the speakers. So if you have any question afterwards about the tools that we are going to present, you can still contact them. Also, we have a website. Here you have the link. And you can also follow us on Twitter. And so there you have more information about who we are and what we are going to do. So to start build this community, we decided in collaboration with the NPPM and thanks to the support of the Midwest Big Data Hub, we created this first workshop series. There are 9 workshops starting from today, and every workshop will introduce you to a new open source tool that you can use to analyze phenomics data, because we know that the most challenging part sometimes is data analysis. And so we want to provide to people like an opportunity to learn which kind of open source are there. But the objective or the aim of this workshop series is mainly making you working on with this open source. So it's an hands-on workshop series. You will have the opportunity to write the commands, to perform the analysis together with the speakers. So since we are many people, we cannot give supports during the workshop with some trouble with installation of tools and data. But at the end of the workshop, there will be 30 minutes Q&A session where you can ask questions to the speakers. Also, consider that there is the Slack workplace where you can still contact the speakers and ask questions. So to make the workshop smooth in this sense, we create, actually Noah created. So thanks to the collaboration of Noah Falgren from the Donald Danforth Plant Science Center, we actually he built an environment on Binder where all the material needed for the workshop is already installed. So every workshop will have a different Binder environment. So we will ask at the beginning of the workshop, we will ask you to connect to this Binder. So to do so, if you register to this workshop, you receive the GitHub link. And if you click on that link, this page will open. And to launch the binder, you just need to click the button at the bottom of the page, which is say launch binder. So it should take some minutes to connect, but at the end you will have, for today, because we are going to use RStudio, you will have this page opening. And so here in the console of RStudio, you can type the commands that Filipe is going to do today. So we ask you to launch the binder now, so you will be ready once Filipe is going to start with the practice part of the workshop. So to open the workshop series, since this is the first time, Filipe is going to be our test. But besides that, so he is the first speaker because he also developed these very cool tools, which is called FIELDimageR, which is basically an open source R package that is useful to analyze orthomosaic images, but has many functions that he's going to explain today. So Filipe is a postdoc at University of Wisconsin-Madison. And so the first part is going to start with about 15 minutes of introduction about the package in general, and then there will be the practice part of the workshop. So I'm gonna leave. I will be in the back, and so I want just to remind that there will be like the final part of the workshop, the QA section, where you can ask questions to Filipe. And then good luck and so you can go, Filipe.
Awesome. Thank you, Narita. Yeah, guys, first of all, we are really, really happy with these opportunities. Thank you, NEA PPN and Midwest Big Data for all support. This workshop's gonna be, our main idea is share, right? So we wanna, our nice environment, what we're gonna plan here today is a chat. So not formality, we are gonna talk. Every question that you have, please send in the comments, right? Also, if you, also we decided to use YouTube because it's easier to broadcast and also is more accessible, I guess. And if you didn't sign yet in our webpage, in our YouTube channel, sign here or here in some point there, because every time that we start a new broadcast or a live or workshop, or we have a new video, you're gonna receive a message, and then you can keep following what we are doing, right? Also, don't forget to like this video because it helps us to communicate and share this information with more people, okay? And what we are planning to do, I'm going to do this short introduction, talk about the package and the examples that we are talk today, and then we're going to start the two examples, right? And between the two examples, we're going to give a break of 5 minutes, okay? What else? Information that I want to pass today before we starting. I talk pretty fast sometimes, and I have this really nice Brazilian accent. So if you didn't understand some point, please comment there and ask to repeat a point again. And Narita gonna come and talk with me, and then I'm gonna try explain again. And the importance here is if you are understanding how to use this tool and think how apply the information, okay? So let's start our first part in our workshop. I guess, let me put the full screen. Here we go. You can see the full screen, right? Great. Today, our workshop is FIELDimageR pipeline, image analysis applied to plant breeding. We're going to start talking a little bit about this tool, FIELDimageR, how it starts. And then I'm going to talk about the first example, which is a UAV image from drones. And then the second example, which is image that we normally take in lab, for example, disease leaves, seeds. So all the time here, please, I ask you to try to connect these examples that we're using today with your reality, with what you need. And please share with us here in the comments if is this possible. Can I apply for example, for seeds? What are you observing here? So feel free to have this communication, okay? Let's have fun and a great time together, because it's around 1 to 2 hours. And I can talk more than that. So you guys gonna see that I talk a lot and super fast. But here we go. FIELDimageR, I started work with FIELDimageR last year, 2019, when I first started work with remote sensing here at UW-Madison, Wisconsin. But back in that time, when I got my first orthomosaics, which is this when we stitch all pictures together from the drone and make one huge orthomosaic, like one huge mosaic. And my colleagues asked me to remove or get information per plot. But when I look, I had a picture, an image, and my first question was, how I do that, right? And maybe many of you guys today have the same question, and you have the same situation that I was last year with an image, and you need to extract information to apply in your reading program, to apply in your research. And kind of accidentally, I started this tool because I start searching online, and normally people there are amazing softwares over there, amazing softwares. But people don't normally use Python. There is the QGIS and other softwares that I don't speak. I don't speak Python. I mean, I don't code Python, but I know R. And then I was learning Python to starting doing my extract data from my orthomosaics. And then all the time, because I have this background in genetic and plant breeding, all the time, my brain, my R brain, say, you can do this in R. And I start trying with some scripts, like we go Google and searching, like how do this, how do that. And I came with some functions, and then these functions was working pretty well. And then I talked with my boss, Dr. Jeffrey Endelman, which gave me this opportunity to work here at UW-Madison. And we decided to share with our community with FIELDimageR, and we officially released the software at Phenom 2020, which was in February this year, February in Arizona, and was a really, really great conference. I learned a lot there. Actually, I met Narita in this conference, and back in that time, we are having exactly this conversation that I'm having here with you guys about the challenges that we have in our research, and how when we are beginners and we have no direction for where to start, and then it's like, why not make some network or some platform where we can talk with people, where people that is starting can go there and see and talk with people with more experience and see what they're doing, which software they're using. And yeah, so basically everything, all this idea about the workshop, all the idea about plant PhenomeForce network group, we start with a conversation across these challenges that we have in our research, right? So this is the FIELDimageR, right? FIELDimageR, we use RStudio. It's a R coding, and we use RStudio to communicate with the software. For the ones that don't have a lot of experience with R or RStudio, I'm gonna shortly explain how the view, how is the how is the face of RStudio, the interface. We have in this part here the coding line where we program and communicate with the software. All objects that we get during this process is in this environment. And right here, because we are talking about images all the time, we are plotting images, and we can communicate also with the software by clicking in this window here, which we call by plot window. We're going to do this almost 1 hour or more today, so we have time to explain this part. I already tried FIELDimage package with different kind of images. I tried with RGB, which is this common camera that we have in our phones or on other, this cameras that we normally everybody has. And this camera has three bands. One band in this region, which is blue, another band in this middle region here, which is green, and another band in this region here, which is red. If you see here, blue is around 400, and green is around 550, and red is around 650 here. So we have 3 bands for this sensor, right? When we have more bands, any one of these bands it is in this other region called near, we call the sensor of multispectral. In this case, I'm showing here this multispectral has 5 bands. One is blue in this wavelength, another is green in this other wavelength, and red, right? Red edge, which is this region when there is a slope of reflectance coming from the red to the near, when the plant really reflecting a lot. Okay, so I'm only trying to explain briefly the sensors and the kind of image that I already tried with the software and works well. And also hyperspectral sensor camera. Hyperspectral, in this case, we have 474 wavelengths here. Okay, this image we got with a partnership with Dr. Phil Thompson from Fit Pathology Department here at UW Madison. And it was super great because we could see this profile in our breeding population. Each line that you guys see here, it's one different genotype in my potato population, our potato population here. And as you can see, when we have a lot of information like these sensors give to us, we can see how the genotypes behaves in different parts in the spectrum, which is super nice, and we can apply this in our research, right? I never tried with thermal information, but I know that some people there are using the FIELDimageR already, and please feel free to share with us your information. So comment here in the comments in this video, and let me know your results. I will feel really excited about that. Okay, so this is the 3 sensors that I had experience work with this package, and it works well. And this image here, all this information was extracted using FIELDimageR, and the code for this in the tutorial. Okay, let's start with our first example. Our first example is one reality for many breeders and many people in plant science, that we normally go in the field and we took pictures, a series of pictures from the beginning when the plant starts sprouting into the end when we have the maturity and finish our crop cycle, okay? So we go in the field. Here's a potato example. I'm gonna use a potato example from Dr. Endelman that I collect here, work with Dr. Endelman and the UW potato breeding program. But this can be applied for any other crop, right? This is a normal question that I receive. If the people normally see that I'm using many potatoes in my examples, and they kind of don't think that can be applied for corn, soybean, or other crop. But the answer, yes, you can apply for any other crop or any kind of image. So today, our first example, you're gonna download for the people that are gonna make the registration and have the binder. Don't need to download, but here you're gonna see there that you have 6 pictures. One is we took at 30 days after planting, day after planting, right? 30 days after planting, 40, 55, 75, and 90, and 100. Basically, what we are doing, we are following this growth cycle here. It's the information that we normally use to collect in field, right? And we can see here how the plants grow differently, because we are talking potato breeding population, how the maturity is different as well, and then how we use this information in our breeding program and how we extract this information. It's what this first example is going to talk about. What we're going to do, we're going to use one of these pictures, probably or 50, 55 or 75, and then we are gonna, here's this image, we're gonna rotate this image to be straight using FIELDimageR. We're gonna remove the soil using a mask. But here I wanna pick your attention for one point. Not necessarily you need to remove the soil, okay? Depending of your question. For example, if you wanna, for example, understand the leaf area index, which give you this idea about leaf area in relation to the soil, you should keep the soil there because this information is going to be important. But if you only want to have the reflectance per se for each genotype, and then that's when you can, for example, remove the soil. I prefer this way, but depend of your necessities, your objectives, right? And then after we remove the soil, the example today we're going to remove the soil, but you can adapt for your reality. We're going to draw the field shape file. The field shape file, basically you're going to see that we're going to click here on the boundaries in this field, and we're going to inform number of columns, number of rows, and then we're going to have this grid. And from this point, we are going to calculate vegetation indices. Actually, here I'm highlighting two vegetation indices, NDVI and NDRE, which is super common and really normally is most used in plant science and research. So, but today the examples that we have is RGB, and then we're gonna use another index, which is RGB, right? We are not having here the near and the red edge. Talking about that, by the way, we collect all these pictures from this example using this drone. And as you can see here, we have the RGB camera and we have the multispectral camera, this green camera right here, with 5 bands. So you remember that we were talking about which kind of sensor and which kind of image that we already worked. So I collect this information with this, right? 5 bands, 3 bands. The example today, we're going to use the information that we collect with this camera here. Feel free to make questions about the drone too, how I collect this information. I was flying 200 feet, which is 60 meters, right? And I was flying 15 miles per hour. 15 miles per hour. Yeah. And yeah, I don't know how kilometers per hour is that. Okay. Okay, we're gonna talk about vegetation indices. And also, in this example, we are gonna evaluate plant height, okay? Do you remember that we have 6 pictures there? And the first picture is only the soil. I forget to talk about that. Did you see the picture? The first picture was 30 days after planting. It's happened because in potatoes, we need to make the hill, which is put soil above the plant for the potato tubers coming this area, right? And it's happening around 30 days after planting here. And when we took a picture and stitch all these images together and make the orthomosaic, one output from the orthomosaic process is what you call digital surface model. That basically per pixel we have latitude, longitude, and altitude. If we connect all pixels together with the altitude, we have this surface model that's gonna give us idea about how it is this environment or this field using the altitude. Basically, to be more clear, let's see here. Digital surface model 0 is that 30 days after planting. You can see here that we have these small hills, right? So these small hills mean we can't see plants, but we see the hills. So that's why important take this picture before the plants start coming out from the soil. And you see here the values is around the altitude here in Hancock Agriculture Station, where we have this experiment, is around 300 meters height. Yeah. And then we go there in the field in the second flight or the third and all the other flights. And now we collect the same outputs from the orthomosaic step, talking about orthomosaics, one of our workshops is gonna be Open Drone Map, and probably they are gonna talk about this output. So don't feel afraid to make questions about this right now. But all these questions probably gonna be better explained in the other workshop. Anyway, and this example here, we took pictures with vegetation growth. And you can see that now we already can see the image, the plants coming here. They are taller, right? As you can see. And what's happened? We have an image right here, the base. And also we have another image right here, the height. When we remove the soil, what we have is the plant height estimate, the estimate plant height. And as you can see now, our reality is around 30 centimeters, which makes much more sense for plant height than before, right? Because we are removing the soil effect. And then here we remove this, the inclination effect. Here we remove the soil and then extract information. So what you're gonna do with this? We are gonna basically today evaluate the area under the curve. I did this post in my LinkedIn a couple weeks ago, and then some people came to ask how I did that and if I could share the scripts. And then I decided that this was a really great example to work here today and share with you guys. So we collect information from 35 days. This is the other pictures, right? This is not exactly the example that we're going to use today. This is only my post in LinkedIn. But basically, you can see how the plants behave 35 days, 40 days, 55 days, okay? And when we select genotypes here, for example, these Czech varieties in our red potato population, we can see that each genotype behaves different in the time, okay? If they behave different in the time, they have area under the curve for this trait here, which is NDVI, NDVI, they have different behavior for each point. And the question is, how can I use this information in my breeding program, right? And there is many options, and we're going to discuss this today during the workshop hands-on. And basically, after you extract area under the curve for all genotypes in our population, you have a really nice new trait called area under the curve that you can apply in your breeding program. So this is the first example. The second example is evaluate images from lab, right? This is really great because at the first I thought this package is gonna, like, I programmed this package to be used for US image from drones. I never thought about the possibility to use for image collecting in lab. And then after release officially in Phenome 2020, the software, I start receiving many messages and people adapting the code to use in their own reality, for example, evaluate disease in leaves. And I felt really, really glad with this possibility. And today we're gonna talk about this, and now I would like to say thank you to Professor Fernando Piotto and the PhD student Jessica Nogueira from Exalc USP in Brazil. They are evaluating this disease, Xanthomonas perforans, and potato leaves. And they have around, our example is going to be 10 pictures, but they have around 14,000 pictures to evaluate. It's just impossible to do this in time and with health, physical and mental health to complete these in time, right? And then we'll work together to try to make a pipeline to evaluate these using FIELDimageR, and we're gonna share with you today, guys. Basically, they do this manual evaluation. They use this scale here, Horsfall Barat, I guess, from 1945, which is super common a scale to use in plant fit in pathology, plant pathology. And it's great. They have this score 1 from 10, and according to the damage area in the leaves. But come here, how in this part here, the difference only 3%. For example, from 0 to 3%, you give a score 1. And in this second score, from 3% to 6, you give score 2. how you use your own eyes can differentiate 1%, like 4%, to give the score 2 from 3% and give the score 1. It's pretty hard, right? When you come here in the middle in this scale is better, because now you have a range between 25% from 25 to 50, 50 to 75. Is better, right? It's easier recognize percentage this way. But when you come here down between 8 score to 10, again, it's only 3% difference in this point. And this is pretty hard to do. That's why we start working together on this example. To be clear, let's see here. When you have one plant, one picture has score 1, like this genotype 35, it's easier to recognize difference with one other genotype, this 138, which receives score 5, right? We can see the difference here, basically. But what's happened in this case? You score 2 and score 3. This score is around 6%, and this score is above 6%. It's really hard to recognize this. And then our idea is use FIELDimageR and R code to make a process to evaluate all this together. And first of all, these need to make sense in my research and your research, but we're going to talk about this later. Basically, what we propose, we're going to evaluate damage area and also vegetation indices here, and try to correlate these with the manual visual score that they collect. Okay, this is the second example today. This package was published. Talk about the references. The package was published on the Plant Phenome Journal. It was great. There we explain many features of this package, and we have the GitHub page here. We have a lot of information there. And also we have this tutorial, everything that I know, every new applicability that I discover, I upload in this tutorial. Actually now it's connected with OpenDroneMap. It's not in my GitHub, but here's OpenDroneMap. But basically it's the same thing. If you go in this link, you're gonna go directly to the tutorial. And in this tutorial, I'm gonna explain you how you're gonna install package, how you can download examples. It's pretty similar what we are gonna do here today, but have more information, right? So please go there, give your feelings, your suggestions. I really like to interact with you guys or with people that are using the package. Actually, I learn a lot with that. With this, I finished my presentation. Probably was more than 15 minutes that I'm supposed to talk. I told you that I almost half an hour that I told you that I talk a lot. But thank you to University of Wisconsin-Madison, and also thank you to UW Potato Breeding and Genetic Laboratory here with Dr. Jeff Randeman, which gave me this opportunity to work with remote sensing, right? With this, let's start our practice today. Let's open the RStudio. Let's stop to share here. I'm gonna share now my entire screen. Please, guys, go here on the description in this video and click in the link called workshop tutorial. When you click in this link, workshop tutorial, you're supposed to see a page like this. Let me share my screen with you. Just a second. Okay. Okay, you can see my screen, right? When you click in this link called workshop tutorial, you're supposed to see this page here. Anahita, can you see the page? Anna?
Yeah, I can see the page. I can see that. Maybe you should increase the text size.
You mean here on the R?
Yeah, maybe yes. Yes. Yeah. Yes.
It's 16, 18. Let's see. Okay, good. Thank you. So guys, for the folks that is using the binder, you're gonna have something like this, right over there, and also you guys already have all the data here in the files. Okay, so when I ask here for downloads, you in your case you not need to download this right now because everything is ready for you. But let's start our workshop. This page is gonna be there for you guys. Go again and try do all pipeline again too. And also feel free to use this information if you are a professor and you are teaching this in your class. If you want to teach this for your colleague or use this in a training, so feel free. The main idea is share. The main idea here is learn with each other, okay? And please give me your suggestions how to improve this. We are harvest potatoes the next 2 weeks. Maybe I'm not be that valuable, but as soon as I have time, I'm gonna answer all questions. Also, talk about questions. I know people that were using the package already, and please, if you see some question in the chat here, please help me to answer those questions too. I really appreciate it. Okay. So let's start our tutorial here, and let me know if I'm talking too fast or too much. Too much I know, but too fast. We have here a short introduction about plant breeding. Okay, how it's the possible traits that you normally collect with these tools. We have here FIELDimageR. In this link right here, I guess you can follow my mouse, my arrow here. Is gonna bring you directly to the tutorial, the main tutorial, and we are here in the first example. So let's start calling the necessary packages that we're gonna use today. So copy here. Today is gonna be a copy and paste. So we're gonna follow this tutorial and we're gonna copy here and paste in our R and see what's happened. So come here. If you did install this package, all these packages, you can use this. For the folks that are using Binder, you not need to install any package. You can come directly here and use these libraries. Let's call FIELDimageR. We are going to use Hoster. We are going to use Agricoli. We are going to use Reshape2, ggplot, LMA4, which it's a free open source package to do mixed modeling, which is great. We have here PLR, this other software, and we have desk tools. And basically what we are talking here is a tutorial. That's why pipeline, right? So we are using FIELDimageR as the main default, but we use many other softwares to prepare the data and run data, okay? Let's continue going in our first example that I explained, the UAV images. And we have in this example, in this trial, we have 140 plots. Our work with potato is amazing because it's a huge plot. See, we have 3 by 15 feet. It's easy to see. It's great work with potatoes, pretty didactic. In this population, we have 97 genotypes, and we have 6 UAV flights, okay? One 30 days after planting, which you call soil-based, there is no plants there. 40, all that data that we already explained today is here. So let's go ahead and download the data. For you download, you basically click here, and this link is gonna open a new file for you, and you can come here and download. Okay, it's downloading there. It's already downloaded. I have the scripts always. I have my script here, and I always put my data together in the same point. I'm gonna unzip this file, and when we look inside, what do we have here? We have flight 1 30 days, flight 2 40 days, and all the 6 flights that we are gonna share here with you today to calculate the area under the curve. Let's clean these. Okay, let's remove this. Now we can again download the DSM file. The DSM file folder is the digital surface model to calculate the plant height that we are gonna talk, right? The same way, click there, download the example. Let's come back here. Download the example again. I already let's put in the same folder that I have my script. Okay, when you look inside, is the same for each orthomosaic that we had before. We had now the digital surface model. Okay, as you see, let me just remove this. So now what do we have? We have our script here. We have mosaic folder with 6 mosaics, RGB mosaics, and we have DSM folder with 6 digital surface model examples. Let's continue in our tutorial, right? Let's start. Go here, copy this code and paste in your R, and let's see what's going on. This function stack is stuck. I don't know if I'm pronouncing it right, but stuck. This function is from this package raster and help us to bring for our environment pictures with many layers. Okay, many layers. In this case, from oops, I jumped one part. Let me take this here. Guys, copy this part first. I jumped this part. Let's start here again. This function helps us to identify all information that we have inside this folder. Our folders is right here now, and when we use this function, they are gonna tell us which files we have inside the mosaic, and then we can see all 6 pictures that we have inside there. Okay, and the same thing for the DSM file. We can see what they have inside, and then we have all these 6 pictures here. Okay, now we can run that code again, and what we are doing here, we are saying to the software, please give me the four information in this mosaic object. The 4 information is the picture at 75 days after planting, because I was looking the data, and I guess at 75 I can really see well where is the plot, and I can draw my shapefile much better. Because basically what we are doing here, we are gonna adjust. I'm teaching you guys how you adjust the pipeline for one picture, and then how you use a loop to run all the other images without need to do this all the time. Like you adjust one and you run the other 5, 6 images that you have from your field at once. Okay. When we bring this information for our environment, we can come here and plot RGB, and then we can see our image from this potato trial at 75 days in the R. Great. For if you are going in the right way, the output also is here at the tutorial. When you run the code, probably you need to see something similar to that. If you didn't see this, don't panic. Try again, start again, and when you get this point, you already understand how to use the software. By the way, I know that for people that is beginning in R, it's hard, but I'm assuming that everybody know the basic of R to do this workshop. If you have problems with R, can talk with me later after the workshop, and I can help you with some directions. How start, how Google it, how find information in Google or in the internet that can help you, okay? But let's assume that everybody's running well and everybody know R. Now, the next point, we're gonna crop the image. In this case, here is not a big deal, crop the image, because I already cropped the image before. But for many of you guys, when you got your orthomosaic, it's not that perfect square on your field. There are a lot of area around your field, and sometimes you just don't want to work with that, and maybe this is a really good strategy to reduce the size of your image, and reducing the size you one time, like the R is much more faster when you have smaller images, okay? And as you can see, we are using now the first function from FIELDimageR called FIELDCrop. And basically we are saying which crop I want to crop, which picture, which mosaic I want to use to crop, to cut the trial. I'm going to use the test, which is this one that is just below. And the software always send a message. I put this, basically, guys, I need to share this with you. I put this message more for me use, because all the time I forget what I need to do in that point, you know? And then turns out that was a good thing for other people too. Other people, because the software talk with you, say, like, now select 4 points around the corner in your field, in this plot area. So you can come here, click the 4 points, and you're not gonna see huge difference here, because I already see there is a pretty small difference, because I already did this before, right? I reduced the size, but in your reality, you're gonna see that makes a huge difference. Okay, we crop the field. Let's rotate. Let's copy this. In this case, I already know which is the rotation. The rotation is important in this case because help us to draw the field shape, which is the grid, right? The grid, easily. In this case, we not need to have geographic positions. You can run this information your own, without going to the field to collect information. But if you need the right position, there is a really nice tools over there also that allow you to do this. Also, FIELDimageR, there is another function that I'm not going to talk today that allows you to do something similar. Please come to talk with me afterwards, and I can help with that. But as you can see here, there is 2 possibilities. I'm going to start. Don't do this last part that I'm going to do right now. I'm only want to show how you first start. For example, imagine that you don't know which is the rotation that you're going to do in your field to keep this straight. What you should do? You come here in the function field rotate. We put here the output that you just crop, and in this case, I'm putting a clockwise false because I wanted the field rotating this way. Okay, need to be false. When we do this, run this code, I come in my picture, and they say here, select 2 points from left to the right in the image. If like, you need to select a line to tell the software how would be the better rotation to put that line straight. In this case here, I'm gonna come here in the first line. I'm gonna click here, another point right here in the back, and it's gonna draw a line. See? And they're saying that this rotation is around 2.21. And as you can see, it's a really it makes my field stay really straight. But my experience with running this data for you guys told me that better rotation is the theta of 2.3, right? So this function here is only to show how when you are starting. Maybe this is take a little bit time when you are beginning, but when you figure out which the best theta, you can use this theta for all the other steps that we're gonna talk here. Okay, we have the theta 2.3 that I'm telling you, believe in me, is the best one. And then when we rotate, this function is going to rotate the field for you. See, rotate the field for you. And it is really important save this rotation, because what's happened? We are talking about 6 pictures, right? That we went in the field and collect. My 6 pictures, they are correctly geographically. I have the ground control points, and with these ground control points, we correct all images. When we correct all these images, it's easier to overlay them, okay? And if I rotate the first image 2.3, I can rotate all the other image 2.3 too. And then everything that I do for 1, which is this test that we are doing right now, I can apply for all the other examples that I have in my trials. Does that make sense? Okay, yeah. I'm asking you, sorry guys. Okay, we just did this rotation, and now we come here to removing the soil. When talking about to remove the soil, copy here, copy, and let's paste. Please write here in the comments if you are following, if you're having problems, and please, Anahita, feel free to stop me if necessary, okay? Field mask. This function field mask is going to remove the soil, and in the official tutorial, there are many ways there showing how you can change parameters in this function to remove background for any other crop, okay? Or select regions according to according to the values of one layer. Also, if you have another question, send us. I can send a link for you with better explanation about this. But here, believe me, that the default for this kind of soil, for this kind of data, works pretty well. And then when you run the function field mask, you're going to see we have the original image. We use one vegetation indice to identify where is the plants and where's the soil. And basically, I told the software, please, everything, we call this image segmentation. The method is thresholding, right? Everything from this point above is plants, return true. Everything from this point below is soil, return false. And then we have the mask. And with this mask, we can have this really nice image here where we remove the soil, okay? But again, remember the importance to keep or not the soil depend of your hypotheses and your objectives. Right, now we prepare the image. We crop our image, we rotate, we remove the soil. Now it's perfect for starting our extraction, right? And to do this, we need to make our grid, which is this field design. And many of us normally go in the field and collect information, which is the ones that we want to use. And I'm going to show how you combine the information from one CSV that you have from your field with the shapefile that we are going to extract information here. I took long to discover how to do that, actually. But I need to do, right? I have time. I need time for, like, I have deadlines to show data, and then we figured out a good way. Good going. Please, guys, come here and download the CSV file. Okay, let's download. Here's the data. I'm going to talk about this data soon. I'm downloading information. I'm going to put this download in the same folder where I have my picture and my script. Let's clean this. Let's close this, close this. Here we are again. So it's here. And then now we can copy this code and paste in our R. Let's read this data in R. This is the function to read CSV. And then when we read this data, we can look this data. See, what do we have here? We have the genotype name, G7, genotype 78. We have which column this genotype are in the field in the reality. We have the row, we have the plot number. The plot number is the only information that we have, 140. Okay, that's really important. We need to have some information that's specifically and the only one there. Normally the plot number, because we have only one plot one, right? And then here's one trait for you guys play with this data afterwards in your own. Then we have the data. As you can see, normally when you go in the field and we are collecting information, we put here genotype 7, column 1 or plot 1, trait 1, trait 2, yield, and all information that you want to combine with the image that we are evaluating here right now. Let's create the map. The map, let's see here this point first. The map is the position of my genotypes in the picture, in the shape, the picture that I have right here now, okay? In this case, my first genotype, I'm showing here. The default, using this code, the first genotype stay on the up part to right. In the default that we are doing right now, using this code, okay? The genotype, the plot number 1 is this plant right here. You guys following, right? This plant right here. However, the real plot number 1 in my field is this plant on the bottom part right here. I need to change this map, or I can make this manually. I can make this in an Excel and bring to the R, but the map must be exactly what you have in the field. Does that make sense? Okay. Let's copy this code. Let's come back here and paste. We are using now this function field map. This function field map, I'm gonna say the column in this data that we just bring from the field, which column is plot, which column is the column, and which column, yeah, in the data is the rows, right? And then we are saying decreasing true. So when we run here, what we have is a matrix with numbers, exactly this matrix that we have here, right? But it should start on the bottom part. And then let's copy this other code. And then we're gonna rotate. This is one function for rotate matrix. It's super cool. We have this, we apply this reverse. So let's run this, and then we run again. We apply this rotation twice in the first map, and when you look this information now, you can see that now it's making sense because our plot number 1 is starting here. And if you pay attention on this tutorial, this year we didn't follow the serpentine or zigzag, I don't know how you guys call, where you come from 1 to 14, and then the 15 is supposed to be here and come this way, right? So in this year, we just plant our fields directly this way, always starting from the left. So I'm only showing, I like this example because I'm showing here that you need to adapt the map according to your reality, and the map, this position should fit exactly the positions here. I guess it makes sense, right? Let's go there and draw our plot shape file. To draw the plot shape file, we are using this function called field shape. And this function field shape, we're gonna say which is the mosaic that we want to work with. I'm taking here the mosaic that I removed the soil, that we just removed the soil. I'm saying how many columns we have. We have 14 columns. If you see, we have 14 columns here. Actually, here 16, but we are gonna, the outside board is the borders, right? So we're gonna select only the 14 inside. We have 10 rows, which many people call by range. And so I have here row 1, 2, 3, 4, okay, into 10. And I'm gonna combine the data that I'm bringing from my field that I collect this data here with trait 1, 2, 3, 4, yield all traits that we have. And I'm gonna say my map, do you remember, my map is order in function of the plot name. In my data, I have the column called plot with specifically plot name. And I'm saying, combine my data from my field with my mosaic map using the column plot. Basically what we are doing here. So when go ahead and click here, and then we're gonna see this first interview, and then the software again are talking with us. Do you remember? The software all the time, the function all the time talk with you. Select 4 points as the corner. So and then I come. As you can see, there is a difference, right, between my plots. I click the first point here in the middle of the alley. I click the other point here in the middle of the alley, in the bottom part. I come here, I click in the middle, and then I come here, and then I try to click in the middle around here. And as you can see, automatically, when you click this area, this square is gonna be split exactly according to the number of columns and the number of rows that we inform the software to do, right? And as you can see, it's a potato. It's a really great example to work with. Depending of the crop, you're gonna have more. You need more time and to see details. But in this case, it's really important to have a big screen to help you to connect, right? As soon as I discover another better way to visualize or give in zoom, I'm gonna upload the function and share with you guys. But right now, it's what we have. Also, feel free, if you have an idea how to do that, contact me. We can upload these. You can come to be one developer with me. I'm really appreciate it. Okay, let's go. Now we prepare our image. We draw our grid, which is this, with our grid, and then now we can calculate vegetation indices using the wavelengths that we have and extract information per plot. So basically, it's what I need to do when I first start, and I had no idea how to do that. And then, fortunately, it's working well now. And every time that when someone contacts me, we always improve this tool. Please, let's have this communication. Okay, let's continue here with vegetation indices. We come select this, copy and paste. We are using now this function called field index. Normally, FIELDimageR functions always start with field, right? And now we are calculating the index. We say which mosaic I want to work with. I want to work with the mosaic that I just removed the soil. I say I can inform the software from this mosaic. The red band is number 1, green 2, and blue is number 3. But if I had a red edge, the default, the red edge is null, and the near also is null. But for example, if we are using the multispectral camera, which is this one right here, the 4th band is the red edge, and the 5th band is the near. But you can change this according to your necessity, right? And in this index, we are gonna select today, we are gonna only evaluate these 2 index, NEGRD, NEGRDI, and GLI, which is green leaf index, right? But the software already come with a list of vegetation indices, and then you can choose wherever is better for you there. But if you don't, if you are looking for an index that is not there, you have this option to call My Index, where you write to the software which equation, which formula you're gonna use. For example, I use a randomly, let's put 2 times here just to have more fun. 2 times red less blue divided by green. And here are the wavelengths that is gonna work. So go ahead and run this code. As you can see, we have the red, green, and blue original that came with the orthomosaic that you collect with the drone. And now we have 3 extra layers. One is the NEGRD, another is GLI, and another is My Index. In the tutorial, which is this Open Drone Map FIELDimageR tutorial, you can see the list of vegetation indices in the number 6. and you have all those vegetation indices here. So, and here's the equation and what they are normally used for. Go there. If you need another vegetation index and you really think that's important to have this vegetation index in this list, we can upload the software and we can introduce these vegetation indices. It's required for many people. Let's continue here. Let's visualize all those information. Okay, now we have a new object. As you can see, do you remember when we started in the environment, we have the objects and test indices is what we have here, test indices. And now when you click here, when you press, excuse me, when you press tab, we can see the red, the green, the blue, the NGRD and GLI or my index. Let's see the NGRD just to show that you can make many changes according to your necessity. When you run NGRD, we can see the layer NGRD and then going from 0 maybe into 0.5 per pixel that you can see. And then we are gonna overlay our field shape that we just draw in this image. See how cool it's gonna be, right? Is that great? And then you can extract the information per plot here, which is the next point. Test information, let's copy this extracting data, copy. Let's paste in our coding space. The function field info is responsible to extract this information. We have what are we extracting here in this point? From test indices, I'm telling the software extract these 3 index that we just calculate. But if you don't want, if you want all the layers there extracted, you just use the directly object this way. But in our case, we want these 3 layers and form the field shape, which is this grid that we just draw. I'm applying a buffer of minus 10 centimeters. What this means? The buffer here, they're gonna 10 centimeters for each alley or each part in the plot. Like 10 centimeters here, 10 centimeters here, 10 centimeters here, is gonna be ignored. Like this part is not gonna be extracted. And I'm telling the software, I don't wanna you extracting 10 centimeters from the border, like only the middle. This is a good way, for example, when you have overlay, one plot overlay the other, for example, the leaves of this plot, it's over the other, you can introduce some bias, and then with this buffer, you can just remove this part and take the central part. This is one option, okay? And in my case, I'm saying to the software to speed up, use 3 core. So let's go and run this part, and they're gonna say here, you can speed up this extraction using core equal 4, which is the number of cores that I have in this computer right now that I'm using, okay? But normally you can put 2, depending on your computer. And then we need to wait a little bit, just extract this information, and then we can see the data extracted here. Here we go. Again, we have plot name. This is exactly the information from the field, the CSV file that I had from my field. And now we had new columns here with the average information per plot of any GRD and also GLI, my index, or any other information that you are, or any other index that you want to extract. Also, one possibility is this parameter called function. For example, if you don't want to see the average, the mean, you can put, for example, max, and then the function is going to take the maximal value from these points here. Again, depend of your necessity or objectives. Okay? And again, here's the output. Okay, we extract the information from vegetation indices, and now our interest is estimate plant height, which is really great when you have this digital surface model, DSM file. Let's go and copy the first part of code and paste in our coding space. Again, let's bring this DSM0 is the first picture. Which is the first picture? 30 days after planting. What I told you guys 30 days after plant was when we cover, when we make the hill and we have only soil there. We don't have plants. It's the base, the soil base. So I'm saying to this code, DSM0 is my soil base. And because we are evaluating plants at level 4, right, which is at 75 days after planting, is the DSM1. I run this, and then just let's see here the DSM1. You can see that we have all those plants here the soil, and by the altitude, we are using the altitude, and that region is around 295 height, right? 295 height. Let's continue in our example. Let's paste. Okay, now what are we gonna do? We're gonna use the field crop again, but here pay attention that we are not gonna click and select the area again. We already did this once in this test point crop there. It's one of our objects that we did at the first. So I can use any shape or field shape or another picture that I already cropped to give us a reference to crop other images. Is what we're gonna do here. We crop only once using the RGB, and now we're gonna crop this DSM file using the first crop that we did there. So go ahead and run this code. It's gonna crop, see the soil base, and then here's the crop. Run the second one. Again, we cropped. You guys remember that here was reduced, right? Now we're gonna do that step. This resampling help us to put exactly one pixel above the other. Sometimes we have a small difference, and this resampling help us to have a really well overlaying, which is important. And now we're gonna make this calculation, right? We have a DSM file with the plants and a DSM file with the soil. When we remove the plants with the soil, what we supposed to have is these values here are here around 0.6, 80 centimeters from the soil, right? Which makes sense. The plant, we are talking the flowering time. The plants, they are taller, and we remove the soil effect, the inclination, the soil, or any difference in the soil effect. Now we're supposed to have only the estimated plant height. Is what we are going to calculate next. Again, let's copy this code. Let's paste here. Remember that I told you, guys, it is important keep and save this data that you're running the first one to apply to all the others. I told here we know that 2.3. I told you guys, and you agree with me that 2.3 was the best to rotate. I'm gonna rotate using 2.3, and now I'm gonna use. Okay, what's happened? This folder here, I have only one layer, and I can make a mask using this, but I already did a mask before using the vegetation indices in our RGB mosaic. And one output from the field mask function is this, what you call mask. And this mask is this white and black binary mask with true or false that help us to remove the soil. So if I already did this before, I can use the same mask to remove the soil from this altitude or digital model or canopy height model that we are doing right now. Go ahead and click. You're gonna see this is the image. This is the soil, the mass that we used before, and then here how is the image after cropping. Great. Let's continue. Now come this nice part. Field info. What we are doing? We are extracting you plant height, estimate plant height information. I'm saying, please use the new mosaic. Remember that field mask give you two outputs. One output is the new mosaic, which is this one without soil. All this area is NA. Another is the mask, which is this other one here. So we want the new mosaic because there's the information that we want. We are using the field shape that we just use, that we just collect or extract the information from vegetation indices, and we want the average, okay? But you guys feel free to try the quantile, which is gonna give you portions of height. For example, the quantile is gonna give you at 0, like the minimum value inside the plot, and 0, 20, 25, 50, 75, and 100%, which is gonna be the maximum value inside your plot. Does that make sense? Okay, go there and change this when you guys running in your own. We are extracting information. Now we have here only one layer. If you remember before, we have here extracting 3 layers because we had 3 vegetation indices. Oh, please let me know if I'm going too fast or I'm going too slow or I'm talking too fast. Anahita, are you understanding?
Yeah, I'm doing.
Thank you. Because I never know, right?
No, it's okay. People are asking questions, so you can go.
Okay. Okay, if you feel free to make the question here too.
Okay, so well, maybe it's up to you. I mean, are you close to the end of this example, or
I'm kind of.
Okay, so do you want to take question about this example before starting the next one, or
yeah, before the break? What do you think?
maybe it's good because some of the questions they are related with some of the function that you have used now.
Okay.
So it will be good to answer them, I think.
Okay.
Okay.
Great. Thank you.
So, yeah.
Okay, let's run the code. Just run extract the information from plant height, and then we see here. See how great it is. We have the ID, the position, and we have the average height for plot number 1, ID number 1, ID number 2, and go this way, right? Great. And then now come the magic. I'm gonna ask you guys to start to run, copy all this code, evaluate all our mosaics in a loop. So go ahead and copy this and paste. And let's start running this. And during the time that this code is running, I'm gonna explain to you what's going on. I'm only gonna clean this space. And then let's run the data and start your loop. Okay, and I'm gonna explain what's happened. What we did until now, we prepare the pipeline for one trial, one mosaic. Now we are gonna apply the same pipeline for all the other trials. How are we gonna do that? Using this possibility, using this function called for, which is a loop function R, and they allows you to make the same code many times according to your necessities. What are we talking here? We are going from, do you remember that mosaic is the name of all 6 pictures that we have? However, the first picture is the soil base, and we don't want to extract information from the soil base. We need to have plants there at the first. And then that's why I'm writing here number 2. Okay, number 2. Number 2, and then here the number of mosaics that we have. And again, the only difference is now instead we are using number 4, we are using y here, and all the code that we just discussed is right here. Okay, so we crop, we rotate, we remove the soil, the inputs that we're going to evaluate, extract the information, and then again we are extracting. We are taking the DSM file from 0 base and then DSM file 1, and we are cropping both. We are resampling, and we are doing the canopy height model, rotating, removing the soil, estimate plant height mean, but you can change for quantile. And here, basically, we are combining this information together in one table. And we have this other function called field plot. Field plot's basically a visualization function for data. You say where the data is, which shapefile is the data, which attribute from this shapefile that you want to show. In this case, we are showing the NGRDI. Which mosaic you want to put as background. If you don't want to put a mosaic, you just write null. Color, go from red to green. Red is going to be the smallest value, like the lower value, and green is going to be the height value, which makes sense because you're talking about vegetation indices. Alpha is the transparency that allows you to see the background. And this round is only to see 2 numbers after the point here in the data. And that is nice because when you're doing this, and then when you are running this in a loop, you can follow all those images coming one after the other. For example, in this case, this plant has really low green values for any GRDI. See? And these others, pretty green, has really high values at this point. And because the software talks with us all the time, you can see during the time that it's running, showing here what's going on, right? And we also put this information here, print, when you complete one mosaic, number I, letter I, yes. Again, everything that you're looking is coming, and it's a really nice visualization from the data that we extract. This is nice for when you have, lab presentations and you're gonna show these, or to the growers to show that this genotype actually, let's suppose that has lower yield, and you can see that it's less green, and you can make this easier to understand for them, right? And we are here. We just complete mosaic number 5, and we are doing the last mosaic, which is when the plant already starts in senescence. And after this, we are gonna start looking the data. Observe here when you have empty plot with an A, it's gonna give you 1 NA, right? So that's the visualization. You guys can come back here and see all the mosaics, the plots during the time. But let's run this code and prepare the data for some analysis. Because now we already run the data, and now we are preparing the data to do analysis. This first part here, I'm only organizing the table. There is not too much to explain. But when we organize the data total that you have, what this new data total information that we have the DAP, like the day after planting, the genotype name, the column, the row, the plot, the one trait that I bring from the field, could be yield or any other, and all those information that we just extract with the software, right? And here estimate plant height. Here this estimation is almost 0, which makes sense because the plants were pretty small that time. Let's run another code, copy this part. Let me close this. Okay, Now we're going to prepare this data to evaluate. I show you guys how extract the information. Now we're going to see how evaluate this information, one of the 1,000 options that is possible. For this example that we're going to work with, we need to make some transformations. For example, some parameters in our data set need to be factors and other need to be numerics for we run some mixed models. And in this case, name, row, column, and DAP is going to be, actually name, row, and column is going to be factors. DAP, NGRD, BGI, and estimate plant height is going to be numeric. It's just some transformation. And this is a really nice code for you see the data that you just extract. Okay? When you see this data at 40 days, we see that normally on the x-axis we have the NEGRDI, vegetation information, right? The vegetation index. On the y-axis, we have the number of genotypes. What we are seeing here is the density plot, the histogram, right? Density plot. And you can see that at 40 days, because the plant's too small, they are not green enough. And then the greenest in our population goes up according to the time until here around 75 days, when you have the flowering time, when the plants are really big and green. And then after this point, the plant starts the senescence and send all these photostimulates to the tubers, and then starting being less green, and then we can see this movement back. Okay, that's super cool. It's a data visualization. The results right here. And let's make some use all those information and give some biologic mean for that. For this, we're gonna evaluate in genetic and plant breeding. We always evaluate the heritability. In a really simple way, heritability is the amount of variability that I have in my data, like the amount of this variability that we are observing here. It is related actually with the genetic variability. Okay, it's not the environment, it's not any other problem, but it's the genetic variability. Basically, is that in a really simple way for people that is not from the genetic or plant breeding. And what I did here is only the same loop for all days, all DAP. So as you can see, we have 5 days, right? And I'm gonna evaluate everything at the same time using the same model. And this is only one option of model. What we are using the function LMR, which from the package called LME4. In this function, I say I'm telling the software I want to evaluate the NGRD. This is a spatial model with row and column, but here you need to introduce and use your field design that you planned before. I'm only give you one example. I'm telling the software that genotype with this name is gonna be random effect and the data. So let's go and run. Understand this part's not the main idea in this workshop, but here you have an example and to adapt in your reality. And we are combining now a new data set where we have DAP, days after planting, and the heritability per each DAP, like the heritability here, 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 and 100 days. When we combine these in this new data frame, we can run the code and have a really nice visualization of this data. And as you can see, we have here the heritabilities, and it's really great. NGRDI really are recognizing the variability of NGRDI is really related with the genetic that we have in our field with super great. Sometimes this trait is better connected with it has, for example, high correlation with yield, and I can use this for indirect selection or make some assumptions that we're gonna talk a little bit later. Talk a little bit more about that later. Okay, I'm sorry, I'm showing here how to do this, and now let's do the same for the plant estimate plant height. Let's run this code. Do the run it again, the mixed model, and make the new plot. As you can see, estimate plant height is not that high heritable for these data sets, for these population that we are working, but at 75 days, which is the most growing point in the potato, in this potato population, will have really high heritability, which is super great. Okay? Nice. Let's evaluate some genotypes and how use these in our exam, in our potato breeding program. Oh, it's right here. Okay. What I'm doing, I'm selecting only 3 genotypes, only to show you guys some output. I select only these 3 genotypes information, and then this code here is a ggplot code that's gonna give you this kind of graphic. Again, x-axis, we have days after planting, and y-axis, we have NGRDI. Okay? And we can see how different these genotypes are. For example, G44 stay much longer like green in the field than the other genotypes. Is this much longer time is related with the yield at the end, or with any other trait that is important for you in your breeding program at the end? We don't know. You need to figure it out. And because the genotypes has these different areas under the curve, the idea is use this information and correlate this with biomass, yield, and use in your breeding program. And then the following code here that you're going to copy and paste is going to do exactly this part. Exactly, yeah. Okay, it's right here. We are going to do exactly this. We're going to calculate the area under the curve for all genotypes in my population. So which traits I want to work with? Let's continue working with NGRDI. And what I'm telling the software in this code here, I'm taking each information per time. Okay, here I have 100 and see, I have 140 plots and their names, and this some code. And again, we're gonna use one loop to extract all this information. So go ahead and start. You guys can see this slowly, the coding line again later. But basically, we are saying which are the days after planting, x-axis, which are the trait, right? The trait information for these, like the y-axis here, x and y, which is this point basically. And I'm using this function, which called area under the curve, to extract this information. Okay, so we have here all dots, all these points, and y, we have all those points that allow us to make this curve. And this function allows you to do this. This function also is nice because you can change which method to use for area on the curve. Let's again prepare this data. Okay, factors, numerics, which is important. When you look this data area on the curve, we have genotypes, we have row and column, and we have the information that specific point around the curve. And here we're gonna copy and observe this area under the curve information. Again, let's use this function to calculate the heritability, right? Row, column, and name as random. We calculate, this is the heritability, and then when we do the plot, we can see this really, really nice shape, right? We can see the histogram distribution, and we have here the density plot, and this is a new trait. It's a really new, nice trait where we have all those area under the curve information per possible trait. You can do this for NGRD, GLI, or any other trait. Okay, and the heritability is pretty high, 91, which is super, super great. Guys, I just saw the time and I really talked too much in this first example. And then I'm gonna stay in this workshop today only in this first example. I'm not gonna start the second example because I need time to talk, and I know it's lunching time in many countries, or maybe too late, and we can have another day to talk about this. I'm gonna schedule with Anahita because I wanna talk better about this the following example. Okay, I don't wanna extend from the time that we decide, but I wanna continue talk about the example number 1, and we can open for questions, example number 1. And then I talk, we have many other opportunities to talk about the second example, which is the lab leaves, but you guys already have the code, and you guys already have here the data for download and follow the code. You guys can try running your own and send me questions if you need, if you have any problem during run the code. It's pretty straightforward here, right? So basically, it's what we're doing, copy and paste, and the tutorial go explaining and showing which is supposed to be the output that you're gonna see in your R, okay? But coming back to the example number 1, now we have this new trait, which is this last part in the example number 1, area under the curve. And then you can ask me, Filipe, how I apply this in my breeding program? So one suggestion that I have for you, I'm gonna share again my presentation. My presentation here. And one possibility is, for example, you can make these graphics. Which graphic is this? We have on the x-axis the trait that we extract from our population. In this case here, in this specific image that I'm showing to you guys, we are evaluating canopy at 40 days, like early canopy. But imagine this with this trait, this new trait that you just extract, which is area under the curve. So you have this information here. And we want to correlate this information with one important trait in breeding, with, in this case, yield in potatoes. And we see this, we can see this kind of regression that we're observing here. These red points is our check varieties. And these blue points is the genotypes in our population that has better yield. Okay, and what's the possibility? Can I use this information to remove, for example, if I select a point here of canopy, early canopy, or area on the curve, that is where all my check varieties are, and remove all genotypes that I have below this point, and keep going in my breeding program, only the genotype that has value above this point. This is one possibility of use. And when you can use this, for example, in potatoes, here at UW-Madison, here's Dr. Endelman, here's my colleagues working. We have visual selection in field year 2, where when you have a lot of genotypes, and we need to walk in the field and select which genotype has better performance according to the breeder perspective, right? And because it's too many genotypes in this point, we only select for high heritable traits, and we do not select, for example, based on yield, because we just don't have time or don't have the structure enough to harvest all this potato and evaluate for yield. And sometimes we have only 1 or 4, a little bit more plants, which it's hard to estimate yield from that. But imagine if you already adjust this information. Okay, you fly the drone there, you collect all those data, and you already know that when you have better canopy, or you have more area under the curve, or you have some kind of more greenness, also you have better yield. And imagine you're going in the field, and then you can correlate this with the traits. For example, in potatoes, we are walking, and then Dr. Enderman said, oh, select this plot. And then we go there and put all those potatoes in box, like you see here. We collect all information from this plot. But in many of those plots, we don't select. We are not selecting this for the next generation. But if we have all those information using drones, and I know that that trait is related with yield, I can put, or I can include this information in my, for example, cell phone, tablet. Here's one option, FieldBook, this app, and it's really great. And then the breeder can walk in the field and check in FieldBook or any other app what the performance for that plot that I'm visually selecting related to the remote sensing image that I collect in my field, that I know that is related with yield or height, any other important trait in breeding. And then I can use these to give confidence to the breeder to make selection, mainly, for example, in this case, where we have visual selection, that we just walk in the field and say yes or no. But now we have some trait information from the entire crop that is related with main traits. Okay, does that make sense, Anahita? Anna?
Yes,
Anarita?
yes, I'm here. Yeah, I see. Yeah, makes
Oh,
sense.
Anarita.
I think.
Yeah.
Are you ready for
Yeah,
questions?
I told you.
I should
Yeah,
have
I told you I
stopped you.
talked too much.
Yeah,
Anyway,
it's
but
okay.
but I guess it's better we keep only with this first example. I want to know your opinion. I want to maybe keep only this example and then talk about the second example another day.
It's up to you. I mean, maybe we go through the question and then you see if some of the question also can be answered with the second example. And I think depends also on people.
Yeah.
Like, yeah. So, because like, I think based on the time zone, there will be people that maybe it's dinner time or lunchtime or like, so.
Yeah.
Uh,
I don't want.
okay,
Yeah,
so
I
we
don't want to extend. I guess we can have another opportunity to talk about the
Yeah, so
second
we'll
example.
see. I will start with the question. So
Okay.
actually, there's been some exchange of like some people already comment or like they were talking to each other, which is great because I think this is like our also like our intention, connect people and make things. But I will like let's say so. The first question is from Vipin. Is asking, are results as good in cereal as also in potato?
Yes. Do you remember when we start and then we say, oh, all examples that we're normally going to use is in potatoes, but you can apply these for any other crop. So that's a really common question that I receive. And the answer, yes, you can apply in any crop, any image that you want to extract information. Okay? Thank you for the question.
Okay, so the second question is from Lisa. She's asking, his multispectral camera make a sense multispectral sensor?
Oh, the one that we use here, this one is from Centera.
Okay,
Centera. Yeah.
so it's for the brand of the camera that she's asking.
Yes. This is the 4K multispectral 5 bands. Yeah. That we are using here. I'm using this drone and this sensor since last year, and I don't have many results published right now because we were waiting to have 2 years of data to starting having more confidence in our results. And yeah, I'm gonna start actually. I'm harvesting the potatoes the second year right now, and then as soon as I have more results, I'm gonna share with you guys. So follow me in the LinkedIn, follow FIELDimageR in our social media, and can share with you guys.
Okay, so the second question is from Irene, which I think she asks something. So she asks, could you explain how do you decide the value of thresholding? I think it was when you were creating the mask. So I think she's referring probably to that.
Okay.
Yeah.
Just give me a little time here, because I talk about that. Just a second, okay?
Yes. Yeah. So probably I should have stopped you at that time. But yeah.
It's because I have a really nice presentation where I explain this better, and I'm gonna share. Here we go. Here we go. Let me share this with you guys.
I will remove the.
You
Oh
can,
no.
you're seeing, right?
Yeah, I will hide the question because so people can look better.
Okay. So basically, this answer I can answer. This method I'm gonna answer this way. Imagine that we wanna count the number of seeds in this picture here, and then we need to remove the background. How are we gonna remove the background? One possibility is to use, in this case, some index, where the index can clearly differentiate where is background and where is the seeds, right? We are differentiate these seeds in only one layer now. Because this picture is RGB, 3 layers. How are we gonna differentiate them in only one picture? We can use an index, okay? And when you do the histogram of these values that we are observing here, we can observe 2 peaks in this specific case. When it's field, like pictures from the field, you're gonna see more, columns here. But in this case, you can see one small peak, which represent the seeds, and one huge peak, which represent the background, which is much, how can I say, much taller, not taller, but much greater than the seeds, right? And then basically you select one point between this, in this valley, in between these 2 peaks, and you can say, for example, 0. From 0 above is going to be false, and 0 below is going to be true. And with this, we create this mask. And based on this mask, you can apply, the field mask function in the original picture, and you select only the seeds. Basically, it's the same principle that we use for remove the soil. This is the threshold method in image segmentation. Does that make sense?
Okay. Yes. Okay. So still Irene, she's asking, which I think you also replied to this question like in the last part, which vegetation index are you using?
Okay, the default in the function is actually not vegetation index. Index is not vegetation index. The name is, oh boy, this is a hard word to say. It's hue. To write, the right is hui, but
Yes.
I guess the pronounce is hue.
Yes.
Anyway,
Yes, I don't know. I'm not
and this hue, the question.
But no, yes, so it's here.
Thank you, guys. So the default, the equation default in the field mask function is a hue specific to identify soil and green. So that's default. But sometimes this is not gonna work in your reality, and then you need to change the vegetation and change the crop value. And in the tutorial, the main tutorial, I explain how to do that. But send messages if you have more questions about this.
She got it because she said, "He okay, thanks." So
okay.
I got.
Thank you.
She got it. Okay, let's see. Oh, still Irene. She's asking, is it possible to export the shapefile?
Yes. To export the shapefile, okay, to export the shapefile, we are here in the main tutorial from the package, right? We have here saving outputs number 17. When you click in saving outputs number 17, you're gonna have the options how you can save the raster, which is the image, and also we have this really nice package called RGDAO, which have this writing FIELDimageR have this function which allows you save the shapefile. And then you can save and use the same shapefile in other softwares like QGIS. And also you can use the shapefile that you draw in QGIS and bring to the R. And we have this option right here. Using shapefile from softwares, for example, QGIS. The same package, RGDAL, they have this function, read or OGR, OGR, and then you bring the shapefile from R. Okay?
Okay.
It's pretty interactive. It is amazing because these tools, they are pretty interactive. You can use everything in each other.
So Heart is function in the tutorial that you share. So maybe if she needs to do that.
It is in the main. I guess I upload these in the main description, YouTube description.
Okay. Yeah. No. They follow that. It's just that source. But I think she say. Okay. Great. Another question from Irene. So it's like, did you experience any limitation in the field size? Some breeding trials have thousands of plots.
Definitely. That's a really important question, actually, because this platform works pretty well for my reality and for a reality of many breeding programs that is smaller, right? We have around 200 plots, maybe 300 plots or more, like around this size. And some people has 1,000 plots. And the only problem is because the space for visualization is small in our studio. We have only that window there. There's some strategies to open an extra window, but still, maybe your computer don't have a screen size enough for you see with details that point. So, and also I didn't discover yet how zoom and the person can go there, click perfectly, how do that. If I figure out, I'm gonna share with you guys. You can
Next
like have
question.
share, yeah, and I can talk about this. But anyway, one suggestion is crop the image in small pieces and then combine this later. Like draw the shapefile for small pieces first and then combine this later.
Cool. Then there is a question from Bipin, which I don't know if was for you or to one of the participants, but basically is asking, have you tried disease assessment from orthomosaic also? If yes, then how promising results are?
It's really, actually, it is super possible. Depending of the moment that you collect the picture is super important that in your population, your field trial, at the moment that you collect the picture, the plants are expressing these disease phenotyping there. For example, if we are walking the field, there is some plants really yellow because, and this yellow is related with some disease that is in that field. When you take a picture and you calculate, for example, a vegetation index, this index is going to be lower because yellow is like express less yellow and then more green compared to one which is resistant. And then, yes, you can correlate these with your disease. But, for example, if you go at the end of the cycle when the plants are already starting the maturity and dying, actually this information is going to be related with maturity and not exactly with disease. So the point that you are flying, collect information must be connected with your hypothesis or with your question. But yes, you can do this in the field. And also, actually, I'm trying to make some disease evaluation with some field that we had some disease this year. And as soon as I have some result, I'll let you know. I share with you guys. Thank you. Thank you for the question.
Okay, cool. So I think there is one last question, which is from Carlos. How are you using this image analysis in trials by multi-environment?
That's a really nice, great question. Actually, if we stop to think, each time that you go in the field, I mean, days after planting, 40, 55, 75, each time that you go there is a different environment in that point, okay? because the weather was different, the plants were in different conditions, but try to extrapolate these for multiple environments. Basically, it's going to be the same, right? But the difference is for each trial, if you change the geographical position, you need to have another field shape. You need to draw again the field shape file, which is the grid, okay?
Mm-hmm.
But if you are using pictures from like many pictures in the time, like we did today in our example one, if you fix the trials in the space using geographical points, you can draw only one time the grid, but the same grid not gonna work in other space, right? Is that make sense? I guess is that kind of
Mm-hmm.
clear? But it's the same. Draw your two shapefiles, extract the data, and combine this data in one data frame to make your analysis. And then here we show some examples, some software, for example, LMA4 that allow you to make mixed modeling, and yeah, basically that.
Okay, there is another question in the meantime from Napi. Can we use this package for here phenotyping in maize?
Definitely. You mean the year in the field or year in the lab? I guess.
I think
I guess
uh,
here, let's think the both situations, okay?
let's
Here
see.
in the field, if you can see and differentiate the ear in the field with some vegetation indice or with some wavelength, yes,
Oh,
you can do it.
there, there is a it's a in lab.
Okay, that's easier.
Mm-hmm.
Uh, okay, we come again here in our tutorial, okay, and then we come here counting number of objects. See, in this count number of objects, I'm showing code here how you do stand count. Basically it's the same pipeline, but a different function. The function now is field count, okay? But you see that we have the plants, and then we apply the mask, and then we recognize this mask. We are count the number of masks.
Mm-hmm.
This should do stand count. But see what this group of people from Lavras University in Brazil did. They had the ear, and then they applied the same code that we use here to count plants, to count seeds in a year. So it is possible. The important point is you need to make a really good mask to remove the background and differentiate objects there. So if you are able to do this, you can evaluate any image that you wanna, any trait that you wanna. But that's the main point, like this image segmentation process, like how differentiate objects. Does that make sense?
Yes, I think yes. But yeah, okay. I think this was the last question. But if you guys have still question for Filipe, you can contact him with his private email, like that he shared at the beginning. But also, like, there is the Slack channel. So if you are interested to join, and you can still contact him there, you just can send an email to phenomeforce@gmail.com, and so we will add you there. I think we are at the end of our workshop. So I will stop you sharing, and I will share.
Okay.
So we can advertise our last.
Just can I give just
Yeah.
a message here, guys? Because we plan to make this workshop around 2 hours, 1 to 2 hours, and I didn't actually. I prefer explain better the first example than start introducing a new topic. But we're gonna try to reschedule another workshop, and then I can talk about the example. But please, in your comments here, give suggestions for us of people that you wanna hear. Okay, Anahita is gonna talk better about this. We're coming from almost all Fridays, following Fridays, we will be here, and I really appreciate any feedback all the time. It's super important for us, and the most important point is we are here to share. We are here to communicate and make network. Okay,
Yeah.
and yeah, go ahead. Anna.
No, I mean, like, that's good. Also, like, yeah, so this is just the first workshop series. I think in the future we will also organize seminars, and so also I think it will be good if you guys have any paper that you want to suggest to the people, we can share it on Twitter and so on. So let us know. So as I say, this is the first of 9 workshops that we plan by Thanksgiving. So the next speaker is so the time is gonna be always the same, 10 a.m. Central Time. And we hope to have still 1-2 hour workshop. And so our next speaker is gonna be Mitchell Fieldman. So he's going to, it's still gonna be on R, and he's going to explain us how to use machine learning to quantify and quantizing fruit and leaf shape. I think in strawberry. So again, I don't know if you guys see the registration link, but we are going to send it. It's the same that you used to register this one, but of course we are going to share this also on our social media. So if you have already registered, that's fine. You are already in our mailing list, so you will still receive the binder link next week. But of course, if you haven't, you are still on time for registering to this new workshop. And of course, thanks for staying. Oh, I want just to say that this workshop is recorded and it will be on our YouTube channel. So if you want to go back and redo the tutorial, you are still like, you can still do that. I think also the binder environment is going to be there. And no, I say yes. So if you want also to use it, you can do it. So it will be so the binder environment is gonna be there till we want to. So I think for the next days it's going to be there. And of course, thanks Philip for this presentation. And see you next Wednesday. Not next.
Just one short note message, guys. Again, register here in our YouTube channel to receive message every time that we're going to start our live, and also when we post new information. Okay, thank you so much for being here with us. I expect that you guys having fun and learn with us today, and see you on Friday, next Friday.
Yeah, see
Bye-bye.
you. Bye.